at some different kinds of equations here. So far we've looked at equations where there's a power of 1 and there's a power of 2. In exponential equations and power equations, the powers are different. In exponential equations, the variable is the power, or is in the power, because sometimes there's more than just a variable. In power equations, the power is not 1 or 2, typically. It could be a 3 or a 4, or it could be a fraction, a decimal, whichever way you want to look at that. So let's take a look first at the exponential equations. We've got the equation that says 2 to the x power equals 32, or 2 to some power equals 32. What does the power have to be on 2 in order to give us 32? And some of you may already know the answer to that. You might already be thinking in your head what that answer is. So I'm going to show you a way, though, that you can solve this that will work well, even when the exponent gets more complicated than just an x. So in order to do this, we have to be comparing apples to apples. And by that I mean we want to be comparing numbers that have the same base. On the left we have a base of 2, and on the right we have a base of 32. The best way to compare it is, if possible, is to have the same base. So I know 2 to the x power. Can I write 32 as 2 to some power? Well, I know that 2 times 2 is 4, so that's 2 squared. 2 times 2 times 2 is 8, so that's 2 to the third. 2 times 2 times 2 times 2 is 16, that's 2 to the fourth. 2 times 2 times 2 times 2. 2 times 2 times 2 times 2 times 2 is 32, which is 2 to the fifth. So I can write 32 using a base of 2, and now I can better compare my exponents. Now that the bases are the same, now I'm comparing apples to apples. In order for 2 to the x power to equal 32, the exponent has to be a 5. X has to equal 5 in order for 2 to some power to equal 32. And that's because 2 to the fifth is 32. In the next one, we've got 3 to the x plus 1 power equals 27. Well, again, in order to answer this question, we have to be comparing apples to apples. In order to do that, is it possible to write 3 to some power to get 27? Well, I know that 3 squared, or 3 times 3, is 9. Let's times by another 3, and we get 27. So 3 to the third is the same thing as 27. Now that my bases are the same, now I can compare apples to apples. In order for the left to equal the right, the exponents have to be equal. So x plus 1 has to equal 3 in order for the two sides of this equation to have an equal value. So let's see here. If I subtract 1, I'm going to get x equals 2. Let's see if that works. Does 3 to the 2 plus 1 power equal 27? Well, 3 to the third equals 27, so yes. And x equals 2 does work. Okay, how about problems where the power is something other than a 1 or a 2? You might look at my first example and say, well, there aren't any powers at all. Well, what you don't know is that when you take the square root of something, it actually does have a power on it. For example, if I want to do 16 to the 1/2 power, what's the square root of 16? Whoops, I already had the 1 there. 16 to the 1/2 power. So 16 to the 1/2 power. The 0.5 is not the answer, that's just the calculator. 1/2 is 0.5. 16 to the 1/2 power is 4. 16 to the 1/2 power equals 4. Well, I also know that the square root of 16 is 4. So the 1/2 power must mean 16. So even though I don't have a power on this equation, the square root means to the 1/2 power. Well, if I want to solve for x, I can't solve for x when it's in two different places. Or better yet, not only if it's in two different places, but if it's underneath a radical sign, a square root symbol. So if I want to get rid of this square root symbol, I need to square both sides of this. Squaring and square roots undo each other. I'll show you that too. So if I had the square root of 16 and I squared it, whoops, now it erased that part. Let's try that one again. The square root of 16 and I square it. Squaring a square root undoes it and just gives you what's inside of there. So if I square a square root of negative 2x plus 8, I'm going to get negative 2x plus 8. And over here I have x squared. Well, now I have a quadratic. And from all of our ways of solving quadratics, we know that in most cases we want to get it so that it equals 0. So I'm going to add 2x. I'm going to add 2x to both sides. And I'm going to minus 8. That way everything's going to be over here on the left. X squared plus 2x minus 8. And I'm going to equal 0. So one way to solve this is by factoring. And you could set up a factor box to do yours. I don't have enough space right here to do that. I know that it's going to be x times x and minus 4, or wait, plus 4 and minus 2. Let's just check quick here. X squared plus 4x minus 2x. That will give me a positive 2x, and then minus 8. It's exactly what I need. So I do have the right factors. And so my answers are going to be x equals 4 or x equals 2. X equals negative 4 rather, because I want to set each of these equal to 0 so that I can solve. And let's go back to our original equation and see if this works. On the original equation, this was gone, and this was gone. So x equals negative 4. Does negative 4 equal negative 2 times negative 4 plus 8? Well, negative 4, negative 2 times negative 4 is positive 8. 8 plus 8 is 16. And when I take the square root of 16, do I get negative 4? Well, is negative 4 times negative 4 give me a 16? Sure it does. So the square root of 16 can be negative 4. And I don't have much space here. So now I'm going to try putting the positive 2 in and see what I get. So does positive 2 equal negative 2 times 2 plus 8 after I take the square root of that? Negative 2 times 2 is 4. Negative 4. Negative 4 plus 8 is 4. Does the square root of 4 equal 2? Sure it does. So x equals 2 is also an answer. I have two answers to that first one. X equals 4 or x equals negative 2. Okay, the next one has a little bit different power. It has a power of 3. And I will show you what I want to do to get rid of that. But before I can do that, I want to get that power so that it's the only thing on the left side of the equation. So I need to move the minus 7 by adding it. And just like on the calculator a little bit, I showed you that squaring something undid a square root. Well, we can do the same thing with cubes. If I take the cube root of the left, I will undo that power of 3. So these basically cancel each other out, or they undo one another, and that's going to leave me with 2x minus 3. And the cube root of 27 is 3 because 3 times 3 times 3 is what gives me 27, if you remember over here on this problem. Oops. And so now I can solve this for x. Add 3 to both sides, I get 2x equals 6. And divide by 2, I find out that x equals 3. Let's just make sure it works. 2 times 3 minus 3 cubed minus 7, does that equal 20? So 2 times 3 is 6. 6 minus 3 is 3. 3 to the third power is 27. Does 27 minus 7 equal 20? Yes, it does. One of these times I'm going to learn that I can't fit this many problems on one spot. Okay, and then the last one is kind of similar to the very first one we did on this side. To undo the square roots, we need to square. So then I get x plus 2 equals 2x minus 7. I want to get my x's together, so I'm going to move this one over to the right. And I want to get my constants together, so I'm going to move the 7 over to the left. And I get a 9 here and an x here. Let's see if it works. 9 plus 2 would be the square root of 11. And 2 times 9 minus 7 would be the square root of 11. So I'm sure the square root of 11 equals the square root of 11. So x equals 9 is my solution.